All right, in this video, I wanted to talk about the variance of a residual, okay? And I'm going to be talking about a simple linear regression model. So I have yi equals an intercept, and then a slope. We have one predictor, and then we have an error term, okay? So what is a residual? A residual is an estimate of that error term, right? So this might be written as epsilon hat, right? Sometimes you also see it written as lowercase e, right? And that's going to be the observed value of yi minus the predicted value of yi. Okay, and so sometimes when you're reading through your statistics textbook, whatever you got going on, you will find this equation, and then you might be in another chapter and reading about something else, and you will find this equation, and then you'll say to yourself, what happened here? It looks like I'm looking at the same thing, but now I have a plus sign versus negative sign. Down here I have these plus signs, and up here I have these negative signs. And this is when students come to me saying, no, there's a typo in my textbook. And I say, no, there's not, right? These are two different things. Okay, so let's talk about that. What's going on here? I know they look very similar, but they're not the same. So up top, this is the variance of a residual. All right. You see here I've written this yi minus yi hat. This is exactly the same thing as the variance of the residual. Okay. And when you're calculating this, you need to be aware that yi is not independent of yi hat. And why is that? Well, if you go back to how do you calculate yi hat, right? Which, yi hat, let me write it here, is b naught plus b1 x I. And when you're calculating these b's, you're going to need to plug in your data, your yi data, right? You'll need actually I equals 1 to n. You'll need all of the i's to figure out. So basically, you plug in all of your y data, all of your x data, when you are calculating these estimates, these least squares estimates of beta. Okay, so because you're using yi to calculate yi hat, you're using the observed value to calculate the predicted value. These guys are not independent of each other. Okay, so then when you want to know, okay, well, what's the variance of yi minus yi hat, you need to find the variance of yi plus, right, using our properties of variance, the variance of yi hat, and then subtract off 2 times the covariance of yi hat, right? This is just using our properties of how do we calculate variance of a subtraction, okay, of a difference. All right, and then if you go through and figure out what's going on here, this is going to be equal to the variance of yi is sigma squared. The variance of yi hat is going to be, well, it's going to be, I'm trying to think of a shorter way of writing this. Let's see, sigma squared 1 over n plus xi minus x bar squared divided by, instead of writing, let me write sxx, which is basically what you see here in the denominator, okay? Sum of squares for the x, all right? And then minus 2 times this same stuff, sigma squared 1 over n All right, and then you can simplify this, pull out a sigma squared, and simplify this, and you'll find that you have this 1 minus, there'll be one of these left over basically, and then you'll have the 1 over, so you just distribute the minus sign. You can do a little bit of algebra to get back to here. All right, so now what's going on here? How come this equation is different? What is this? Okay, notice that this notation, you will find this not notation when we are finding prediction intervals. Okay, so this is for a prediction interval. Okay, and when we are constructing a prediction interval, we use this not notation because we're trying to say that this prediction, it's not an observed value of y. Okay, we're not using I, we're not using 1, we're not using any number, right? I equals 1 to n. We're purposely trying to stay away from those, and we're using this not notation to notate that this y is not an observed value of y. Okay, so in this case, when we are trying to find a prediction interval, y naught is independent of y naught hat. All right, because theoretically y naught, right, it's not observed, and so it did not go into the calculation for y naught hat. All right, so y naught is not observed. Okay, that's why we use the not, and we don't use the I. Okay, so because of that, now when I go to find the variance of y naught minus y naught hat, I don't need that covariance hanging out in the back. Okay, and so because I don't have this, I end up with just this piece right here. Right, and then you can do a little bit of algebra and you'll see you can pull out a sigma, and then what you get is what I've written here. Okay, so it all comes down to what you're calculating the variance of, right? This is a variance of an observed residual. This is a variance of a theoretical difference between a non-observed value of y and then what that predicted value may be, right? And remember, when we construct a prediction interval, what we're trying to do is we're trying to construct an interval for this guy, right? And so that's why we needed to calculate this variance. Okay.